Hi everyone. Today we'll discover Rolle's theorem. I could tell you what Rolle's theorem is right away, but then you would not remember it for long. If you discover Rolle's theorem yourself, you will remember it much longer. In the first exercise, we must draw a function on the interval from 0 to 4 that satisfies these three conditions. If you would like to try this exercise on your own, stop the video now and download these notes using the link in the video description. The first condition says that the value of the function at 0 and at 4 must be 2. This means that the function must start at the first green dot I just added to the graph and must end at the second green dot I just added to the graph. The second condition says that the function must be continuous. I must be able to draw it without lifting my pencil. Finally, the derivative cannot be 0. This means that I cannot simply connect these two dots with a straight line, because then the derivative in many places would be 0. I also cannot connect these two dots in the following way, because then there is a place where the derivative is 0, where the tangent line is horizontal. I cannot connect these two dots this way, because then there are even more than one place, in fact 2 places, where the derivative is 0. The only way to satisfy all these three conditions is to draw a function that has a corner. Now, on the first segment, the derivative is not 0. On the second segment, the derivative is not 0. And at the corner, the derivative does not exist, which means it is not 0. The question in the second exercise is similar. This time, we must draw a function that satisfies 4 conditions. The first condition, the second, and the fourth are exactly same as in exercise 1. There is just one additional condition here that says that the function is differentiable between 0 and 4, meaning the derivative must exist between 0 and 4. I suggest you stop the video now and try to draw this function yourself. I believe it is not possible to draw this function. It's not possible to find a function that satisfies all 4 conditions. If I wanted to draw this function, and let's say I started drawing it up, at some point I have to go down to reach the second dot. In that case, there definitely will be a place, let's call that place by the letter C, where the derivative at that point, f prime of c, is 0, because the tangent line there is horizontal. If I started the function by drawing it down, at some point I will have to go up to reach the second point. Again, there would be a place where the derivative would be 0. This is exactly what Rolle's theorem says. Rolle's theorem says that if you have a function on an interval ab, that f of a equals f of b, the function is continuous on AB, and it's differentiable between A and B, then there must be at least one place between A and B such that the derivative is 0. There must be a place where the derivative, the slope of the tangent line, is 0. Let's see if we understand this theorem by completing 3 problems. In the first one, we are asked if there is a number c in the interval between 0 and 2, where the derivative of this function equals 0. We need to determine if all the assumptions of Rolle's theorem are satisfied. The assumptions are: the function is defined on an interval ab, and f of a equals f of b, f is continuous, and f is differentiable. Let's try them one by one. Is it true that the function is defined on the interval between 0 and 2? And it is. Nothing is stopping you from plugging in any number between 0 and 2, 0 and 2 included. Now, is it true that f of 0 equals f of 2? Let's compute those 2 values. When I plug in 0, that is the same thing as sine of pi times 0. That is the same thing as sine of 0, and sine of 0 is 0. When I plug in 2 to this expression, I will get sine of pi times 2, which is sine of 2 pi. Sine of 2 pi is 0. F of 0 is f of 2, which means that the first condition is satisfied. What about the second condition? Is this function continuous on the interval from 0 to 2? I believe the function pi times x is continuous, the function sine of x is continuous everywhere, which means their composition is continuous everywhere, which means I can conclude that sine of pi x is continuous on the interval from 0 to 2. The second condition is satisfied. Is it differentiable? To see if it is differentiable, I will simply take the derivative and see. When I take the derivative of the function sine of pi x, I take the derivative of the inside function. The derivative of pi times x is just pi. The derivative of sine is cosine of pi times x. Now this function is defined everywhere, which means it's definitely defined between 0 and 2. This exists in the interval from 0 to 2, which means that the function, the original function, is differentiable. All three conditions are satisfied, which means there is some number c where the value of the derivative is 0. There is some number c between 0 and 2 where the value of the derivative is 0. In problem 2, we must determine if Rolle's theorem applies to this function. If you would like to try this exercise on your own, stop the video now. I believe Rolle's theorem does not apply here, because this function is not even defined at x equal to 1. You're not allowed to plug in 1 to this expression, because then you will be dividing by 0, which means this function is not continuous. This function is not continuous on the interval from 0 to 2, because it's not even defined at x equal to 1, which means that Rolle's theorem does not apply here. We cannot use Rolle's theorem to conclude that there is a place where the derivative is 0, that there is a place where the tangent line is horizontal between 0 and 2. Finally, we will try to understand Rolle's theorem in more physical terms. We drove along a straight road for 3 hours. After 3 hours, we got back to the starting point. Was there a point during your trip when the speedometer showed 0 miles per hour? Thinking about this logically, it had to be the case. If you left your house and started driving on a straight road forward, and at some point you got back to your house, that means that at some point you had to stop, turn around, and start going back, which means there was a point during your trip where your speedometer showed 0 miles per hour. To use Rolle's theorem for that, you have to ask yourself, is position function continuous? Is position function differentiable? If I call a position function by s of t, that's a position function, then ask yourself, is it first true that s of 0 is the same thing as s of 3? According to this problem, it is true. You started your trip and ended your trip at the same place. So your position at the 0th time is the same thing as your position after 3 hours. So the function starts and ends in the same spot. What's more, s of t is continuous. You do not teleport yourself from one place on the earth to the other. You continuously change your position in the world, which means this function, the position function, is continuous. Finally, is s of t differentiable? And I believe it is differentiable everywhere. You don't change your speed from 40 miles per hour to 20 miles per hour right away. You slowly go through all intermediate values. You press your accelerator or you press your brake, and you slowly either accelerate or brake. So if you want to ever turn around, you cannot be going 20 miles per hour one way and then immediately 20 miles per hour the other way. You have to go 20, 19, 18, 17, all the way to 0. You stop, you turn around, and then you drive the other way. The function of position function is differentiable. All three conditions of Rolle's theorem are satisfied, which means there was a point during your 3-hour trip where the derivative of the position function was 0. which means the velocity was 0, which means that your speedometer showed 0 miles per hour.